Welcome to The Explainer. Today, we're diving into one of the biggest mysteries out there, consciousness itself. I mean, what is it really? And what does it actually look like inside our brains?
For centuries, this was a question for philosophers to debate over. But not anymore. A team of scientists decided they wanted to find a real, physical answer, something they could actually measure. So they went looking for it in the brain's electrical activity.
So to figure this out, we're going to have to think like detectives. We need to understand the two main tools the researchers used. Think of them as our high-tech magnifying glass and fingerprint kit for analyzing what the brain is doing.
All right, our first tool is a concept they pulled from physics, and it's called entropy. The scientists use this to get the big picture, to measure the brain's overall flexibility, basically to see how many different tricks it has up its sleeve. The best way to think about it is like a huge, sprawling city. A brain with high entropy is like a metropolis with countless possible routes and traffic patterns. It's got maximum flexibility. It has the entire map of possibilities open to it at any given moment.
Now for our second tool. This one measures something called pattern complexity. We'll just call it complexity to keep it simple. This tool gives us a microscopic view, zeroing in on how unpredictably the brain's patterns are changing from one tiny instant to the next.
So if we go back to our city analogy, high complexity is like the chaotic, ever-changing flow of traffic at one single, super busy intersection. It's not about the whole map, it's about the unpredictable, moment-to-moment dance of the cars.
Okay, so this is the crucial point. We've got two different tools. Entropy measures the total size of the brain's entire playbook, all the possible states it can be in. And then complexity measures how erratically the brain is jumping from one play to the next. Two very different things.
All right, with our tools in hand, let's start examining the evidence. First up, we're going to look at brains that are in what you'd call pathological or unhealthy unconscious states.
And what they found in epileptic seizures? Well, it's striking. When consciousness is lost during a seizure, the brain gets locked into this rigid, repetitive loop. And look at the chart. Both its overall flexibility, its entropy, and its moment-to-moment unpredictability, they just plummet.
And in coma patients, we see the exact same story. Their brain activity shows dramatically lower entropy and complexity compared to healthy conscious people. It's like our bustling city has ground to a complete halt.
So at this point, the answer seems pretty obvious, right? Unconsciousness just means the brain is less flexible and less complex. Case closed. But this is where the mystery takes a really fascinating turn, when we look at a totally natural form of unconsciousness, sleep.
And here is the big twist. During deep sleep, just like we'd expect, the brain's overall flexibility, its entropy, takes a nosedive. But get this. Look at the complexity. The brain's microscopic, moment-to-moment chaos can stay just as high as when you're wide awake. Wild, right? This surprising clue from the sleeping brain is what finally lets us crack the case. It helps us pinpoint what truly separates a conscious mind from all these other states.
And here it is, the final verdict. When we lay out all the evidence side by side, a really clear pattern just jumps out. Take a look. Only one of these measures consistently drops whenever consciousness fades, no matter what the reason. See it?
So here's the bottom line. True, wakeful consciousness isn't about that moment-to-moment chaos. It's about the brain having a vast, flexible range of network configurations available at any time. It's about having the largest possible map of where your mind can go. And this is exactly what the researchers concluded. High complexity on its own just isn't enough. I mean, that microscopic unpredictability is still buzzing along during deep sleep, when your brain is busy processing information, but you aren't there to experience any of it. And what's so cool is that this idea doesn't just exist in a vacuum. It fits perfectly with some of the biggest scientific theories of consciousness. It suggests that to be aware is to have a brain that's capable of exploring a vast, ever-changing landscape of possibilities. So, all this leaves us with a final, really provocative thought. This research shows that our brains can be incredibly complex and active, even when we are completely unaware. It makes you wonder, what other sophisticated work is your mind doing completely behind the curtain of your own consciousness?